Welcome back for part 2 of our 3-part series. We're going to be making here library functions to convert into and out of our barycentric coordinates. And so the first thing we need to talk about is, how are we going to make u, v, and w? Well, a barycentric coordinate is also known as an aerial coordinate. If we take a look here, our formulas to produce them are basically the area of triangle CAP divided by the area of triangle ABC. So u is being defined as this smaller triangle's ratio. So what portion of this is related to this entire ABC triangle. And so we know that one of the functions we're going to need to make is a quick function that can help us find the area of a triangle. Fortunately for us, we have some, this is a fairly decent explanation of barycentric coordinates. We're going to end up using this calculation here. We're going to basically create ourselves a parallelogram using these 3 points, use cross product, and then just divide it in half, and then that'll give us the area of our triangle. And then we'll use that just a bunch of times to define our u, v, and w. So let's go ahead and jump into Unreal here, and we will make ourselves our library functions. So the first thing I'm going to do is right-click, go to Blueprints, and I'm going to go to Blueprint Function Library. And we're going to call this our barycentric function lib. All right. And so this first function, since we know we need it, this is going to be calculate triangle area. And let me dock this up here so it's a little bit larger and we have some more space to work with. Okay, so we know for our equation here, we're using cross product for our 3 points. So we know that we need to have 3 different vector inputs. And I'm specifically going to want basically the positions of A, B, and C. So we'll call this vertex A, or triangle point A. Make this one triangle point B. And our third one will be triangle point C. And we're going to spit out a float value because we're just spitting out an area. This is going to be triangle area. We can even make this a pure function because we're not going to have to do any special calculations here. This is actually going to be probably our most straightforward function. And so what we need to do here is we need to basically take position B minus position A. And if you're wondering where I'm getting this formula from, on another monitor here, I have this particular formula, already pulled up, and we're just going to basically put this inside of Unreal so we can use it. And so there's our first portion, and we know we need the C minus A. I'm going to give myself little labels here to work with. So this is going to be B minus A. This one is C minus A. We will take the cross product. So we're going to do this. B minus A cross C minus A. And now for this next portion, we just need the length of this vector. So instead of doing any crazy math, I'm just going to, use the function get vector length. And we know that this value here is from the description. We've got a parallelogram right now. So I just need to divide whatever this value is by 2. And now we have our function here that will give us the area of a triangle. All right, so the next thing that I'm going to do is we're going to make a function that will go from points into our UVW. So this one's going to be, vertex. This is actually going to be called into barycentric coordinates. Make that convert into barycentric. And we know that we again need 4 points for this. So we need the 3 points of a triangle and our position inside of it. So let me give myself 4 vectors. We'll call this first one now point position, or player position. And then we'll call this one triangle point A, triangle point B, and the final one, triangle point C. And we'll worry about our outputs when we get to the end there. All right, so the first thing we know we need to do to calculate our UVW is we need to find the areas of each of the smaller triangles. Pulling this back up, we know that we need triangle CAP, ABP, and BCP. Tongue twister right there. All right, so let's calculate those out, and we're going to store those then. So we're going to give ourselves a couple floats to work with here. So we're going to call this one area of ABC. Let me get rid of those spaces. It's one of those OCD things for me. Area of CAP. Area of ABP. And area of BCP. So now we just have to calculate out and produce these points. And again, we can probably make this function pure too, because we're just doing a bunch of math here again. This isn't anything that actually needs to be calculated out with any logic. So first, let's give ourselves, actually no, we do need, if we're going to be setting variable values, I guess locally, we might need that off of pure. So here's our area of ABC. Let's calculate that real quick. And I will grab myself my, if I hit compile real quick, I will grab myself my calculate triangle area function. And so here's A, B, C. And there is our first triangle. Let's give ourselves a sequence here just so we can kind of clean up this visually. I'll make sure I have 4 inputs here. Well, actually, we need a couple more than that, but 4 for now. All right, so the next one we need is CAP. So we will drag that over here, make a copy of our calculate triangle node. We will send it points. So we will start with C, go to A, and use player position as the final one. There is our area for that triangle. All right, let's do that again. We'll get ABP this time. I'm just going to use some comments here. Area of ABC. Area of CAP. Copy that, paste it. Now we need the area of ABP. So A, B, P. Store that there. Give it a little comment box. ABP. And for our final one, we need the area of BCP. So paste that one more time. Here's B, here is C, and here is P. Store that. And now we can put a comment around that. Area of BCP. And now we have all of our areas that we can work with, and we can go to the next step, which is basically just some quick division. So let me add another node here. I'm going to add a reroute because I want to wrap this entire batch over here around with this is calculate areas. Actually, I will. And then this area here, we're going to actually calculate UV and W. So we need some local UV and W's that we can spit out our values into. This is going to be just called simple, call it U, V, and W. And so let me just grab each of these. And so U is equal to the area of ABC. And so CAP divided by ABC. There's U. Ourselves a sequence here. I'm just kind of cleaning things up right now, just to make sure everything's visually very clear. Calculate U. And then we know that V is ABP divided by ABC. And then clean that up. Calculate V. And our final one is going to be BCP divided by ABC. Now, we could have done this, using a math note or something like that, but I kind of wanted to break this up just so we can kind of visually work with it a little bit. But if we were trying to make this a little bit more optimized, a math expression node is probably the better way to go. But instead of worrying about that at this moment, we're just kind of doing it manually. Calculate W. All right, so here are our UV and W. The last thing we need to do is, at that point, give us some kind of a value to export. I'm going to wrap these up basically into a vector since we have 3 different values, just to make sure that it's a little bit easier to just basically transfer it through to another program or another function, that kind of thing. So I'll add myself an output here. We're going to have this output. This is going to be our UVW coordinates. Drag that down there. Just for cleanliness sake, I will add in calculate UVW. I will output that return node. And to plug the values in, I'm just going to right click, split the pin structure, and we're going to just plug in UVW. Now, we are going to want to potentially add in another little bit of logic here, just so that it's more useful to us down the road, because we're not going with a pure function right now. We can add in just a little bit of logic to this, just a little bit. So at the beginning of the first video, or in the first video, I mentioned that UV and W will add up to 1. And so what we want to do is we want to return, with this return value here, just something that we can let the person know if the value that they've given us, because this is dependent upon the point position, the player position, basically, relative to these 3 points. If they're outside of it, this value that we've made, this UVW, is practically meaningless. It's not going to return anything useful to us or useful to the user or any other function, and so it could be potentially useful to know, if these are like these are valid coordinates. And we want to be able basically have a return value here that we can just check real quick to see you calculated something, but was the player in the right area, that kind of thing. And what we're going to do here is we're going to calculate that based off of whether or not these coordinates, I got a reroute node here, whether or not these coordinates were in fact equal to 1. And so what I will do here is we will add in a branch. Actually, you don't even need a branch for this. Let's just do this, we can just use this logic-wise. We can grab these values here. I'm going to drag them out a little bit farther. And we're just going to go float plus float, add another pin. And then just some logic here of is less than or equal to, actually, a value. And that value is 1. I am, though, because I know from testing and such, I am going to increase this value ever so slightly, just because I know from previous experience working with Unreal, there are some rounding errors that are going to occur with some of these values, particularly in the area section. And so if this is equal to it or not, if it is less than this, it'll be a good coordinate. It is valid. If it's not, it won't be valid. We can still get the coordinate values, and we could check it ourselves if we wanted to, but this will give us a good, quick initial check. And I'll just add this around of check if coordinates are meaningful. There we go. And so there's our library function to convert into Barycentric. And so now we need to convert ourselves, or create ourselves a function that is convert out of Barycentric. And let me rename that. All right, and so what we need here for our input, we know we need our barycentric coordinates. So I'm going to have a vector here for these are our barycentrics coordinates. We also now need a triangle to go into effectively. So we're going to need a point A, point B, and a point C. This is going to be target triangle point A, target triangle point B, and target triangle point C. And we already know that we need an output, and it's going to be a player position, and we just need a position out. So this is going to be position out. Now, the fantastic thing about this is that if we give this valid coordinates, meaning that the coordinates are going to be located inside of that initial triangle we went into the coordinates with, if those are valid, this is going to be valid 100% of the time. So this can be a pure function. We're just doing some quick math. And so now we just need to multiply these out properly. And so I'm going to split my barycentric pin here. Remember, this is UV and W. It's kind of awkwardly named here. But just remember UVW. And so our new coordinate is going to be basically a combination of these. So give us a vector float. So we're going to do vector times float. I just know I need 3 of them. I'll plug in. So point A needs point W. And to know how you're doing that, let's go back to the documentation real quick. And so it's explained kind of, should be explained here. Point A needs W, U needs B, V needs C. And the reason for that is basically those are the opposite points. So if this is our U, we're doing U times this B position, W times this A position, V times this C position. And that's what you can see there. And so, yeah, so our A, so the point A is going to be times this one. And our point B is going to be times this one. And our point C is going to be times our V. Then we just need to add these together. And this will give us our new position relative to our triangle, as long as we're inside of it. Compile that. There are 3 major functions then for our library functions. In the next video, we will go through implementing and kind of testing and that kind of thing. And so I'll see you back then.